standard form to factored form.
Okay. Where should we go for that? Do you know?
I think chapter 7 is what she said.
Okay. Standard form to factored form. Okay, I think I know what she's talking about. In other words,
Yeah.
this is actually what everybody needs practice on. It's just almost hard to get too much practice here.
Yeah, I have 3.6 in algebra, which is an A.
Okay, good. That sounds really good. So here's standard form. In other words, standard form is ax squared plus bx plus c, and you can say it's equal to 0, but the standard form would be this, which, if I let that equal to 0, it's in standard form. Now, the most important theorem in all of algebra is one that says if you multiply two things together and you get 0, then
They can't figure out.
one of them has to be 0. You can't multiply two numbers together and get 0 unless one is 0. You can't find two numbers that multiply together and give you 0 unless one is 0. So the secret to solving this standard form quadratic is factoring. In other words, if I can make this the product of two things, then I can solve it. I can't solve it like that. I just don't know how to solve it. We don't have the algebra techniques for solving it. But what they are is to factor it. So, how does that factor?
Well, what our teacher would have us do is find the greatest common factor.
Okay, but there is none here.
Yeah, so how would you do that?
Well, we need to factor it into two binomials. Okay, and I have a three-step process that I use. And it may not be what they teach you in class, but you can't go wrong with it. To me, it's the easiest, simplest, most straightforward way of factoring. Step 1, split apart the x squared. Well, x and x. In other words, the very first term, after I multiply these two things back together again, the very first term is going to be x times x, so it's got to equal this. Second step, figure out what the signs are going to be, what that sign's going to be and what that sign's going to be. Well, in this case, the way you do that is you examine the sign on the constant. That sign right there. The fact that that is a negative tells us what about these two signs down here?
That one of them's a plus and one's a minus.
Exactly. So I can write that. Now, I could also have written minus and plus, but it doesn't matter. Because the associative property holds, it's not going to matter whether it's minus over here and plus over here, or plus over here and minus there. So the only thing I really know is that the signs have to be different. They have to be opposite. Okay? Step 3. What factors of 2 that subtract, because of that negative sign, to the coefficient that is in front of the middle term, which is a 1. Okay, you with me? So factors of 2 are 2 and 1. Well, those subtract to 1, so that's perfect. Now, I'm going to put the larger factor, this is the final step, 4. I'm going to put the larger factor, 2, with the sign of the middle term, which is negative. So the 2 goes with the negative sign. There, the 1 goes over there.
Alright.
Okay? Now, let's talk about checking whether we did it properly or not. I don't need to check this term. When I constructed it, I made sure that I had x and x. So I know that that part is correct. I don't need to check that term because I broke down minus 2 into a, it's 2 factors, so I know that's correct. The one thing we have to check is the middle term. Well, how do you get the middle term in a quadratic? You get it by multiplying the 2 insides together and the 2 outsides together and adding those. So plus 1 times x would be plus x, minus 2 times x would be minus 2x. Add them together, you get minus x. That is our middle term, therefore we've done it correctly. Okay? Now, that's the final step in factoring that quadratic. But if we actually had an equation that we were trying to solve, now notice I have this thing times that thing equals 0. That's what I'm looking for, because now I can set this equal to 0, x plus 1 equals 0, which means x would be equal to minus 1, or x minus 2 equals 0, which means x is equal to 2. So those are my 2 solutions. And if I go back into my original equation and plug in both of those, in other words, if I plug in minus 1, this is true. And if I plug in 2, this is true. So I get exactly what I expect, which is 2 solutions to a quadratic. Quadratics almost always do have 2 solutions. Okay? So that is the basic procedure for factoring. Let me give you another one. Let's go through our 3 or 4 steps. What's step 1?
Step 1 would be to put both x's in the parentheses.
Step 2.
Step 2 would be to put 2 positive signs or 2 negative signs, whichever you choose.
Which is it in that
Next to the
case?
x's.
In other words, this plus tells you that the signs have to be the same, right? They either have to be minus minus or plus plus. Well, how do we tell which it is?
Can you?
Yeah, look at the sign of the middle term. Since that's plus, it's got to be plus plus. Because otherwise I'm not going to be able to produce a plus in the middle term. Okay, so that's my second step, figuring out what both signs are. My third step is factors of 10 that do what?
Add to 7?
Yes. What are factors of 10 that add to 7?
5 and 2.
There's your answer. If we're solving an equation, what are my 2 solutions?
Would it be... I'm not sure.
Okay, let's set each thing equal to 0. So we're going to set x plus 5 equals 0. What solution does that produce?
Oh, -5.
Okay.
And then
And what's the other solution?
-2.
Okay, good. All right. Let me give you another one. Step 1.
You put the x's in the parentheses,
Step 2.
and then you make it minus and plus.
Step 3.
You find factors of 10 that subtract into -3.
Actually, they just need to subtract to 3.
Oh, alright.
Okay? In other words, we're looking for factors of 10 that subtract to 3. Well,
Oh,
that's 5 and 2.
I get it. Because,
Right?
yeah.
There's only two possible factors of 10, 10 and 1 and 5 and 2. So 5 and 2 subtract to the number 3. Well, where does the 5 go? Where does the 2 go?
The 5 goes on the left since it's the bigger number.
Right. The bigger number goes with the sign of the middle term.
Alright.
Okay?
And then
One more. Yes, and then we would solve that, and our solutions would be plus 5 and minus 2, right?
yeah.
All right.
So basically for your solutions, sorry.
Yeah, no, you're right. It's always going to be the negative unless you end up with something like, if I came down and said 2x minus 5 was equal to 0, well, then the solution is not plus 5. The solution is 5 halves.
Oh, okay.
Okay? So it's not always just the negative of that number. Kind of depends on if there's a coefficient in front of the x or not. And we'll get to that, but you're not going to get to that for a while. You're going to be solving, in other words, the hardest kind of factoring problems you're going to be doing for a while are going to be all where the x squared term has a 1 as its coefficient.
Alright.
So let's get good at these. Once you get to a situation where there's something other than a 1 there, then it becomes a lot harder.
Alright.
We'll get you perfect at these before we go on to the others. So let's do this one.
You would get x's in the parentheses, and since, would it be minus and minus?
Yes.
Alright. And then you find factors of 16 that add into 10, or, wait, so,
That's correct.
alright, okay, which is 8 and 2.
Okay. Let's talk about finding factors for a moment. When you're finding factors, always start with that. And now, a relatively easy way to find the other factors is to cut this one in half and double the other one. Can I do it again? Yes, I can cut 8 in half and I can double 2. So I've come up with 3 sets of factors without even trying hardly. Okay? So that can be a helpful little tip if you're trying to factor hard numbers like 88 or something. But yeah, 8 and 2. So what's my solutions?
Alright, so your solutions would be 8 and 2.
Okay, good. Now, let's try next level of difficulty, and I only want to do this because hold on a moment. Let's change this. Now this might be a little bit harder than what you're used to doing. I'm not sure you've gotten this far yet in your algebra course, where you're having to factor quadratics that don't have just x squared, that have a coefficient in front of the x squared. Well, the very first step is to see, is there any greatest common factor that we can take out?
No.
Okay, so the steps now are a little different. They're not exactly the same. First step is the same. Split apart the 2x squared. How am I going to do that?
You would have x times 2x?
Yes. In other words, that works. Whenever you do these, always make sure that this times that equals that first term, because that's the only place that first term comes from, is the first term of this binomial multiplied by the first term of that binomial. Now, you might ask yourself, is it ever correct to do it this way? Because, after all, 1 times 2x squared is equal to 2x squared. And the answer is no, it's never correct to do it that way. In other words, the very first thing is always split up the x's and then do whatever you have to do to make it multiply together to give you that 2x squared. Okay, now, second step, same. What are the signs?
Signs would be positive and then negative.
Opposite. Now, in this case, plus minus is not going to be the same thing as minus plus.
Oh yeah, because there's a...
Right, because the coefficients are different. So you're going to have numbers multiplied by that number, and this number is going to multiply by this number. So plus minus is not the same as minus plus. Okay? So the way I do it is I write both. I'm either going to have this situation or I'm going to have this situation. And I will narrow it down quickly. What are factors of 3?
1 and 3 are the only ones.
That's it. So we don't have a lot of choices there. Now, you got to throw out all of the rules that I've talked about. You can't say factors of 3 that subtract to the number 5. That no longer applies. Okay? You can only use those simple type rules when you're dealing with x squareds only.
Alright.
Once you get a coefficient in front, then you know it's factors of 3. In other words, we still have to produce that minus 3, and the only way we're going to do that is by having a 1 and a 3, or a 1 and a 3, or a 3 and a 1, or a 3 and a 1. We got 4 choices. And this is the point where factoring becomes a little bit of trial and error. I'm just going to randomly try 1 and 3 in those 2 spots. Now, again, I don't have to check this term. I know it's correct. I don't have to check this term. I know it's correct. The term I'm concerned about is the middle term. What do I get for a middle term with my first choice of 1 and 3?
You would get, well, since it's plus minus.
Well, that's plus 2x, right? This one's minus 3x. In other words, I'm multiplying this x times that minus 3. Forget the plus minus for a second. Let's just start with the top one. Okay. So if this were the solution, my middle term needs to be minus x, right? And it's not. So that's not the right answer. So let's try putting the 3 on the left and the 1 over there. Now what's my middle term?
Now your middle term is 6x. Then yeah, and you get 5. You get a positive 5x.
Aha! That's key. It's not the right middle term, but it's the right number. As soon as I get the right number, I know the solution. The solution must be minus 3 over here and plus 1 over there.
All right.
Notice that that produces the minus 6x and the plus x, which gives me a final answer of minus 5x in the middle. So when you do these harder quadratics, it's kind of a trial and error process, but it's still relatively easy. And that's the way you do it.
Okay.
Okay? All right, David, I will talk to you next Tuesday. Is Tuesday at 4:30 still going to work for you?
Yeah.
All right. Talk to you then.
Awesome. Thank you.
Bye-bye.